Hi, this is Niki Sensei. Welcome to Niki in Japan. Today, I'm going to solve a physics problem that focuses on force and Newton's laws of motion. So, let's start. So the problem reads, a girl pushes a toy car of mass 0.12 kilograms on a flat frictionless surface. The car starts from rest and it reaches a speed of 2.5 meter per second. The toy car is in contact with the girl's hand for 267 milliseconds. 1. Calculate the average force exerted by the girl's hand on the car. Okay, so we're looking for force, and we know that force is equal to mass times acceleration. Let's check the problem for the given items. So in the problem, it states that the toy car has mass of 0.12 kilograms, and the problem doesn't mention any acceleration, so I'll put a question mark there. But in the problem, other given are, let's read, the car starts from rest. So that means the initial velocity, so that's I, the initial velocity of the car is equal to 0 meter per second, and the final velocity of the car equals 2.5 meter per second. And then the toy car is in contact with the girl's hand for 267 milliseconds. So the time when the car was in contact with the girl's hand is 267 milliseconds. Okay, so what can we make use of this given? So we know acceleration is defined as change in velocity, so that's v final minus v initial over change in time. So time final minus time initial. From the given, the final velocity is 2.5 meter per second, and the initial velocity is 0 meters per second, 0 meter per second. The final time is the time in which the girl's hand was in contact with the toy car, which is a total of 267 milliseconds. The initial time would be 0 because that's the start of the period. So we have 267 milliseconds, right? But I want to convert 267 milliseconds to seconds. So I do that by using dimensional analysis. I know that 1000 milliseconds equals 1 second. So in dimensional analysis, I start writing the given number, the given variable, which is 267 milliseconds, and then I multiply that with my conversion factor. My conversion factor is 1000 milliseconds equals 1 second, and I can also rewrite that as a factor of 1 second over 1000 milliseconds, or 1000 milliseconds over 1 second. Okay, so going back to my conversion here, dimensional analysis. So I will write dimensional analysis here. So I multiply 267 milliseconds, which is my given factor in the problem, to my conversion factor. So this is my conversion factor. So since 267 milliseconds is in my numerator, I would make use of this conversion factor so that later on I could see that second would be in the denominator and the millisecond would be in the second will be in the numerator and millisecond is in the denominator. So later on, I can cancel out the millisecond term. So I would have 1 second divided by 1000 millisecond. So that lets me cancel the milliseconds here because this is in the denominator and this one is in the numerator. So I'm now left with 267 divided by 1000 and my unit is seconds. But 267 divided by 1000 is just 0.267 seconds. Now going back to the acceleration problem here, acceleration is now equal to V final minus V initial over T final minus T initial. So acceleration, we have 2.5 millisecond minus 0 millisecond over 0.267 seconds minus 0 second. And that is equal to 2.5 millimeter per second divided by 0.267 seconds, or that is just 2.5 divided by 267 equals, so the acceleration is 9.363 meter per second squared. Meter per second, where's the correct? Squared. Or I have to express this answer on paper. I'm expressing all my final numbers into the least amount of significant figures. So I use the variable velocity, which has 2 significant figures, and time, which has 3 significant figures. So the least amount of significant figures from the problem would be 2. So I should express this as 9.4 meter per second squared. Now that we have acceleration, we can now solve for force. Mass times acceleration. So force is just 0.12 kilogram times 9.4 meter per second squared. But I will use the whole number, this very long number in my calculator and multiply that to 0.12 kilograms so that my answer is more accurate. So I recommend you doing that so like your answer wouldn't be wrong for overestimation. So I'm multiplying this number times 0.12. So that gives me force equals 1.1235 kilogram meter per second squared. Or, since the significant figures, let's count the significant figures of the given variables we used. For mass, it's 2 significant figures, and for acceleration, it's 2 significant figures. So I'm going to express the final answer into significant figures, which is 1.1 kilogram meter per second squared, or the SI unit of force is Newton. So to answer the problem here, the average force exerted by the girl's hand on the car is 1.1 Newton. Let's go to the second question. State how Newton's third law applies as the girl pushes the toy car. What is Newton's third law? So Newton's third law states that for every action, there is an equal and opposite reaction. So that means when the girl pushes the toy car pushes her back, but in opposite direction. So a good example would be when someone slaps you in the face, your face slaps back that someone else's hand. Yeah. But for this example, as a girl exerts force in this direction towards the car exerts back the same force but in opposite direction. So That's Newton's third law. So that's it for now. I'll post more physics problems in my YouTube channel. I hope this helped you in reviewing for upcoming exams, especially for the senior students right now. All right, thank you. If you have physics problems that you wanted answers with, feel free to reach out to me on Facebook, Instagram, or on my email. I'd be happy to work out on it. All right, that's it. Bye.